Well, good afternoon, everybody. I'm here to announce my candidacy. No, I'm not here for that. It has been suggested, Jesse Schrader suggested that, but I had to politely decline. Count on it. So thank you very much for being here this afternoon. My name is Richard Searle. I'm the Vice President of Confidential Computing at Fortanix, and essentially, as it says in my title, I live, eat, sleep, breathe confidential computing. What I'm here to talk to you about today is not technology. So if you're interested in confidential computing technology, now's the time. I'm here to talk to you about how confidential computing technology gets applied in the real world, in the wild, solving problems that we heard about this morning. But before I begin, and since he's in the room, I'd like to thank our hosts, Opaque, and also the Confidential Computing Consortium for putting this event on. I think this is going to be one of those moments as an industry where you'll be able to say you were here, not just for this talk, but for the event in general. So congratulations and thanks for doing that. So some of you might not be familiar with who Fortanix are. We are co-sponsoring the event, so we do have a booth over in the expo area. Please feel free to come along and talk to us. I'm told we have the most outstanding thermo cooler bottles for your water that anybody's ever seen, so do wrap those up before they disappear. But our company was founded in 2016 by co-founders. Anand is now the CEO, who I work for directly. We're based in Santa Clara, just down the road, but we operate globally. And one of the other things is we've been one of the pioneers in the field of confidential computing. And I'm going to explain how some of that technology has now come to fruition in some of the things we do with customers. We were also an inaugural member of the Confidential Computing Consortium back in 2019. I was at the first event in Lyon. Some of you may also know me as your general members, or one of your general members representatives now to that organization and chair of the End User Advisory Council. So we play an active role there, and along with the other members of the consortium, we're trying to help with some of the ambitions that Mike set out in his keynote address this morning. We had our Series C round last October, led by Goldman Sachs Growth Equity. You can see a range of investors on the slide. We're also backed by In-Q-Tel, and that gives us a presence within US federal agencies, both civilian, military, and intelligence. And we'll talk about one of those projects as we go through the slides. I've started putting greater than signs on the slide for a number of employees and customers because since that Series C, we're growing really rapidly at Fortanix. And as you can see, we're, I think, rated as one of the fastest growing private companies in the US. So the reason for sort of highlighting that on this slide is it should give confidence that a lot of the work that's been done in the early days of confidential computing is now actually driving growth for us as a business, for all of the other companies that are represented here today, and for the technology as a whole. We've won a lot of awards, of which we're very proud, and that again sort of represents the interest in the application of confidential computing from a data security point of view. And if you go to conferences like RSA, which was held across the street earlier this year, you'll see that there's more and more companies being founded around the technology. So we believe that that's a good thing. There's plenty of space for everybody to play in the sandbox, and hopefully this conference will drive that growth forward. So what I'd like to talk about today is what I call the problem of data encryption. So we're going to talk about a use case that came to us through one of our customers, and frankly, when the use case was introduced to me, I thought, well, surely this has been done. This doesn't sound like anything new. But it turned out that was not the case, and I'll explain why there's a problem with data encryption and how we managed to solve it. And I'm going to do that by introducing you to a solution that's been publicized this week called Fortanix Confidential Data Search. We actually sort of teased this at the HIMSS Healthcare Conference in Chicago earlier this year, and again at the RSA conference that I just mentioned. And these are some of the headline announcements from the press releases that went out on Monday morning or Tuesday morning, I think, this week. And this is an industry first. Our customers came to us because they looked around within the data security industry at a range of different privacy-enhancing technologies and hadn't found a solution. And we took our capabilities at Fortanix and built the solution that I'm going to illustrate to you today. So why was the solution needed in the first place? Well, I think we're all very familiar with the growth in data protection regulations. You know, I come from the UK. We used to be part of something called Europe, but we've still maintained alignment with the EU general data protection regulations. This is a really important regulation, not just because of the scope with which it applies within Europe, but it's actually extraterritorial in its provisions. So if you're working with EU citizens' data in the US or anywhere else in the world, you're actually under the auspices of EU GDPR. What we also see in our interactions with customers and the work that I do with other governments around the world is that people look at those regulations in other jurisdictions further afield, and they're taking what I would call a best practice approach to defining their own regulations. And so we're seeing almost clones of things like EU GDPR, HIPAA, which is regulating healthcare data in the US, and that's being formulated into local regulations that will apply elsewhere throughout the Middle East, and particularly the Asia-Pacific region. You might have also heard about something called AI. I think the first two words I read on the slides when I walked into the main conference this morning were generative AI. And frankly, that's all anybody wants to talk to me about nowadays. But we had recent ratification of the draft of the EU AI Act. And also something that's happening here in the United States is the drafting of what's been called an AI Bill of Rights. What's really interesting about these regulations is that they broadly incorporate the provisions of data privacy regulation. And so governance of AI is actually about governance of data. A lot of people are looking, what I call to the left, at models and how we're going to develop new models and what these models are going to do. And actually outside of Fortanix, I do some work around autonomous weapon systems, which are a very controversial subject for fairly evident reasons. But the crucial point here is control of the data governs how these systems are going to operate and be deployed. And so that's where privacy-enhancing technologies like confidential computing have a very strong role to play. So the purpose of the talk is really to talk about three things: the enabling of something called confidential information retrieval, and to do that, maintaining regulatory compliance. And that was really what we were tasked with by our customer. And what I want to do is just flag this quotation from that customer to you, or one of their representatives, a very senior representative. And they're not really that worried about data protection regulations. And one of the problems here is that although there are extremely punitive fines for data breaches, what we find in practice is that those fines are effectively like a mosquito bite on the back of an elephant to some of these companies. What they're really concerned about, as you can see here, is losing their license to operate. They're worried about the SEC saying, you're not operating within the scope of our regulations, and that's going to have a direct impact on their business. And so the solution that we've built is designed to ensure compliance with their operational regulations as much as it is with their data protection regulations. And this, again, plays into the theme from this conference about protecting all of your data and making sure you're compliant with all of your regulations. So let's put the problem in context. This bank, like many other organizations, is subject to siloed data across different functional activities. And they might want to interact with their supply chain to understand, you know, some of the things that are going to impact their business, but those supply chain organizations are third parties here. They might also want to interact with their customers. We've heard about applications of the technology in retail, for example, and we've seen evidence of applications of data clean rooms for things like mediation or intermediation between consumers and brands. They might also want to interact with the regulators, and I'm pretty sure they would in the finance industry. But they might also want to interact with competitors. And we've done work which has been published previously on anti-money laundering and financial crime prevention. Raluca referred to that in her keynote address this morning. And so sometimes you might want to be interacting with agencies and customers where that information is extremely commercially sensitive, but nevertheless generates value for you. But all of these different silos have to be partitioned. And so we have effectively a need to manage our data vertically and also horizontally across the business. So we need a technology that's flexible enough and adaptable enough to be applied to this problem space. And in terms of use case requirements, this doesn't just apply to banking. We've also seen this in healthcare, and we've also seen this in the military and intelligence domain, and I mentioned that use case that we're going to come on to. And effectively, what we're trying to do in deploying this solution is to provide a framework for the customer to operate, securing their data, and it has to meet certain criteria in terms of things like total cost of ownership, overall security provisioning, and also, crucially, auditability. We have to be building a solution that is available to comply with the types of scrutinies that competitors and regulators are going to apply to it in terms of exchange of information and market dynamics. So these are effectively the use case requirements that were set out for us when this problem was defined. And I mentioned work in the intelligence community. We actually did a project some years ago now, very early in our applications of confidential computing as a discrete offer in 2020. And this was for an intelligence customer that actually wanted to integrate classified information with unclassified information from the public domain. And naturally enough, they wanted to mask the application and the use case for that data and the identity of the analyst and the agency involved. So we built this system. It's a matter of public record. It was recorded as part of a DISA, that's the Defense Information Security Agency in the US technical evaluation meeting. So it's a matter of public record. And what this solution did was it deployed an Elasticsearch database to gather that information and then to serve private queries across the classification boundary so that information that was gathered from public sources was collated without any exposure of the identity of the client, in this case the agency and the agency analyst. And then it was integrated with classified information in order to enable their sensitive data processing. All of this took place within trusted execution environments. At the time, we were using Intel SGX. There's obviously other technologies now more widely available, which we'll see when we come onto the solution. But this formed the basis for our approach to the problem that we were set. So why look at confidential computing? Why hasn't this problem been solved before? Well, it turns out that we're working with a very sophisticated bank, and they've done a lot of internal research looking at different technologies. And naturally enough, one of the things that they looked at was the use of cryptographic methods. But as we heard in one of the presentations again this morning, the serious problem here, and it was something that we witnessed in the competitive evaluation that we undertook as part of that DISA process, is that cryptographic methods simply don't scale. They're not fully developed today. They can't process the volumes of data you'd expect from a global bank. And also, when they are used to conduct search, as the granularity and resolution of that search increases, the modularity of the cryptography increases, and effectively they become intractable in terms of servicing the operations. Confidential computing, as was presented by Raluca this morning, effectively processes information in plain text in the same way as it would in an unsecured world. It's effectively being secured by that trusted execution environment boundary. And while there's a small latency penalty for crossing the I/O boundary, the search is being executed in the same way as it would be natively. The advantage that that has is that as your search granularity increases and you're reducing the amount of information you're processing, it becomes faster. And so there's actually this divergence between the performance characteristics of cryptographic systems involving homomorphic encryption and our confidential computing technology. There was also mention this morning of tokenization. We support tokenization at Fortanix through our Data Security Manager product, but tokenization is not protecting data in use. And one of the other problems is that when you're looking to do very complex searches, you may not know all the tokens that you need to retrieve from that database. And you don't really want to be indexing that database because indexes are prone to change, data's a live thing. And so tokenization solutions are very limited. You can do equivalence queries. Again, we support that today out of the box. But if you want to do something like a range query, as we'll see in the demonstration I've got for you today, you can't do that unless you know all of the tokens. And so solutions needed where you can provide those complex SQL queries. Confidential computing provides a perfect hosting environment to do that. So what are the benefits provided? Well, effectively, when we presented this to the bank actually earlier this year, it ticked all of the relevant boxes in terms of application. What we're able to do with this technology is to service an enterprise scale demand. We're able to provide things like data sovereignty based on attestation, and those attestation proofs being isolated to particular CPUs or virtual CPUs. And what we're also able to do is to use those attestations to provide proof of execution and to provide that mutual interaction between applications to ensure the integrity of the system. And actually, software integrity is another good reason for using confidential computing, because that's not available with homomorphic encryption. You're encrypting your data, but you're not really certain what's actually happening under the hood. And so this is a perfect technology within the AI domain for demonstrating things like explainability of your models in terms of what data was processed by which model version and what outputs were generated. And the other crucial criteria, particularly when you're dealing with very large sums of money, I suggest, is that you get 100% accuracy back. This is a noiseless system, and that's crucial. Cryptography involves noise when you're using homomorphic encryption. And in fact, an attack was published at the beginning of 2022 on some of the typical homomorphic encryption libraries that are in use. And one of the mitigations was to introduce more noise. That makes your system less accurate, and that's not a good thing. You know, as some economists said, $1 billion here, $1 billion there, soon you're talking serious money. So let's look at the solution in practice, and I'll just give you an overview of our Data Security Manager product, some of the features that are built into that that actually run within confidential computing. So the first thing that Fortanix did when it was founded was build the Data Security Manager product. This runs within the Intel Software Guard extensions environment. It's deployed on a clustered architecture, so it's fully scalable. It scales in a linear manner as well in terms of the number of supported transactions, so it can be used worldwide through our SaaS solution that we operate through 16 different data centers, and it can be scaled to the level of data that needs to be processed, and also those clusters can, of course, themselves be isolated for data sovereignty reasons. Out of the box, it provides full enterprise scale cryptography, including, as I mentioned, tokenization, as well as encryption, secrets management. And it also provides the access and permission controls and policy management that's necessary in order to restrict access to data. Whilst we want to secure the data within confidential computing, we also want to control access to both human users, the analysts that are doing those SQL queries, or machine users, applications that are submitting queries in order to recover information, potentially to construct data sets for AI training or for application in downstream AI pipelines. And this is fully supported through a range of very flexible interfaces that are fully cloud native. So we're also able to support any hybrid infrastructure where confidential computing is enabled. So in terms of the solution methodology, it features trusted execution environment attestation across multiple platforms. We're able to implement role-based access control and also to control down to field level the availability of information. So responses, as you'll see, can be recovered either fully decrypted, where permissions are allowed, partially decrypted, or fully encrypted to be passed down to secondary applications. And importantly, we also incorporate local cryptographic acceleration to provide the levels of latency necessary within a global banking environment. What's also important about the solution is that it comes from a single pane of glass as Data Security Manager with control of the keys resting with the data owner. We'll see in the demonstration that that provides a many-layered permission control set, so that even when systems are being used within trusted execution environments that have been validated, access to the data can be shut down immediately with a simple toggle through an API or via the UI. And what's really important about this is that the solution is providing this sort of full lifecycle data approach, where data is protected at rest through transparent data encryption with the databases, in transit via TLS between the trusted execution environments with the TLS endpoints actually within that TEE domain, and then in use when the data is being processed. So there's never any exposure of plain text information beyond that supported by the permission set. And that can also be controlled both through multi-factor authentication, but also with quorum approvals. This is supported across all of the hardware platforms that we support today, both on Intel, AMD. We'll see a combination hybrid architecture in a second, and also AWS Nitro Enclaves, and we'll be supporting NVIDIA confidential GPUs for deployment of this solution later in the year. So let's just take a look at this in practice, and the example that we'll see that we presented with Microsoft Azure and their team at RSA involves PostgreSQL. The reason this is an interesting database is that we weren't able to deploy this in Intel Software Guard extensions because of a shared memory requirement. But what we're doing here is we're using the available Azure confidential computing services to deploy the SQL client within Intel Software Guard extensions on a standard VM. And then we're using the Azure container instances as a serverless deployment of the database in order to service the demand. With transparent data encryption of the original database, so that can service those equivalence queries without any need for recourse to this complex architecture. And all of this is facilitated through our Data Security Manager system with the role-based access control and enablement through things like the Azure Marketplace. So let's take a look at this in operation just under the hood. So this is the Data Security Manager environment with the overlay dashboard. These are the encryption keys that we're going to use to protect our data. This can all be configured through transparent data encryption. And then what we're going to do is deploy our services using the Azure console or independently. This can be orchestrated through our confidential computing manager service. We're deploying our Data Security Manager accelerator tool. We're deploying the database clone, and then we're deploying a standard SQL interface. So there's no differentiation in the experience for the user of this system between a secured and unsecured environment. So here we have our PG admin interface. We're going to sign in as normal using the credentials that are linked back to our Data Security Manager account. And here we're going to run some queries and demonstrate how we can recover information both in an encrypted format, pulling a table with the encrypted data back, and then we're going to look at how we can decrypt that data very simply through the queries that we're providing. All of this is API supported. We're showing this in a sort of CLI format for the purposes of demo. So we can run standard SQL queries in a standard SQL format in exactly the same way the analyst would expect. Retrieve that information. The information's encrypted based on the permission set that's associated with the user ID of that analyst in Data Security Manager. And then we can decrypt data according to those permissions in order to compose data sets or extract information from the original database. And what's really interesting about this, as I mentioned, is that still enables key control at the data level. As I mentioned, we're a data-first multi-cloud security company. So here we're going to toggle the permission set for the data encryption key. And this time, even though we have permission to run the system and the system's running securely, when we look to execute a query, because the key to the database has been disabled at source, we're not able to pull back information. And this is also a fundamental benefit of our external key management services for the cloud in confidential computing in order to provide that isolation for data sovereignty and things like Schrems 2 protection in Europe. So I hope that was an interesting overview. I'm just going to reflect briefly on the opportunity in terms of how this technology could be driven forward before we take some questions. From an existing standpoint, what this is enabling is compliance not only with data protection regulations, but also compliance with those operational regulations. The bank needs to be able to demonstrate that traders aren't colluding, for example, and that data being shared across different jurisdictions is being protected in accordance with their requirements. This has been a particular feature of the bank's operations in Switzerland with us over the last couple of years, and we have a forthcoming use case on that coming up. What we're also able to do is to look at the future in terms of the opportunities within the AI space, in terms of selecting data, providing provenance to data, and also demonstrating through cryptographic methods what data was associated with each model. And this, I think, is going to be a particularly important domain, as has been mentioned before, for confidential computing in terms of providing the protection of that information within the AI pipeline. So we're particularly excited about this, and we have some work ongoing at the moment in the area of generative AI, as with everything, but also more specifically around the introduction of data for very large-scale operations with some government agencies in the US. We also think it's very important from a regulatory transparency perspective, because whilst the data can be secured internally within the bank and within its processes, there is the opportunity to provide external access for regulators to actually monitor what's happening within these systems, and that could prove important under the AI regulations we mentioned a little bit earlier. So we're seeing considerable drivers for this following the preview announcements. It's available in preview now. One of the customers we're working with is a company called Equidium Health. This is being used with a large US military agency at the moment for evaluation of healthcare benefits within the context of that agency's operation. And the quote from Heather as the CEO of Equidium sort of demonstrates this as being an enabler. And one of the thoughts I'd like to leave you with is that we're talking about confidential computing as a security technology broadly today, but the way that we try to position it at Fortanix is as a business enabler. It creates the opportunity for innovation, not in data sharing, because we don't share data, in data collaboration. And that really is the engine oil of the AI era that we're moving into. So just to summarize, we're enabling improved data collaboration. It's really the first example of confirmation information retrieval. There hasn't been anything that's really represented this as a complete end-to-end solution across the data lifecycle. And the customer evaluation has supported that. It also supports not only the environment that we're operating in today, but some of the more complex environments we're going to move into in the future with AI. And it's available across all of the range of supported hardware from Fortanix. And we're expecting this to go to GA at the end of the year. It's in private preview, and I'll be more than happy to talk to you about it in the expo. So I hope that was interesting. Do come to our booth. Do feel free to pick up a copy of our Confidential Computing for Dummies book. It gives you more detail about the technology, and you can find more details on our website at fortanix.com. So thank you all for listening. I've got 1 minute 49 seconds for any questions, if anybody has any. Otherwise, we'll call it a day there. All right, that's a wrap. Thank you very much.